Good evening and welcome to the BS and Beer Show. BS stands for Building Science, of course. Tonight's topic is everything you ever wanted to know about advanced framing. I don't know Tim well, but I do know Mike. We did the first fine home building house a few years ago when that was done with advanced framing. I know Mike will share some pictures of that. And I do have a bit of a history way back. Tim and I used to both be on the break time forum on fine home building back in the old days. My name is Mike Maines. I'm a residential designer in Palermo, Maine. Tonight I am drinking a Maine Beer Company. It's really hard to see, it's a plain label. Maine Beer Company India Pale Ale called Lunch. It's a very good pale ale and it's a really cool company. They're a B Corp, employee owned, do all kinds of cool stuff, and they make a great beer. At the BS and Beer Show, like we say every week, we really encourage local groups. This show started as a result of the COVID lockdown, but it started, BS and Beer started as a local discussion group, and there's about a dozen set up around the country now. And actually our newest one, or pending one, Greg O'Byrne in Australia is planning to start a local group. So we have potentially gone international. So if you want any tips on starting your own group, let us know and we'll give you some tips. And I would like to thank our media partners, Green Building Advisor and Fine Home Building Magazine. And I will turn things over to Brian.
All right, thanks, Mike. Hi, everyone. I am Brian Pontalillo, longtime editor at Fine Home Building Magazine, currently working on Green Building Advisor. So I will launch that now, and I will throw things over to, I always forget, Travis. Emily. I had a 50% chance of getting it right.
That's okay. I've been gone for 2 weeks, so you just forgot about me. So I'm back.
That's right.
So tonight I am having an Allagash White from Portland. Always a good choice. Nice light beer for the summertime. I have the pleasure of introducing our guest tonight, but first I just wanted to say we have an email sign up for the BS and Beer Show. So if you're not on our email list, pop over to the bsandbeershow.com and join the email list. Sends updates every week for upcoming speakers and also to join the show that night as just a reminder. So join the email list. We may also launch a poll in the list there too to get some information on the shows that you like and what we're doing. We also have the recordings from the BS and Beer Show. You can go from Green Building Advisor and check those out on the YouTube channel. So we can put it in the chat box, but it's just the bsandbeershow.com. So tonight we have Mike Guertin and Tim Uhler. Mike, the only thing he liked better than building new homes is remodeling old ones. Can't wait to hear more about that. Over the last 40 years, tackling everything in residential construction, he's still challenged every day to find more efficient ways to build things better. Mike works hard and plays hard, so don't be surprised if you bump into him above 10,000 feet hiking, kayaking, swiftwater rivers, backcountry skiing, or biking back roads. So it sounds like you'll find him outside. And Tim, you get the high five and cheers tonight for the shortest bio. So I can't wait for Travis to have you tell us more about yourself. He is a lead carpenter for Pioneer Builders in Port Orchard, Washington. And he is a contributing editor to the Journal of Light Construction and Tools of the Trade. So over to you, Travis.
Yeah, hi, I'm Travis Brungart. I run Catalyst Construction in Kansas City and also with a couple of friends run the local BS and Beer discussion group here in KC. So I'm drinking tonight a gift. A gift beer is the best beer. And this gift beer is from my friend Dan Edelman of Rockwell. He's a home brewer. He's got this Jew Brew brand. And because he knows my my love of sour beers and light beers, he brewed up a watermelon blonde just for me. So I'm feeling pretty special tonight, just saying. Anyway, yeah, that's enough about me and my beer, but I did want to give Tim and Mike each an opportunity to say a little bit more about themselves. If there's anything that we left out about you, Tim, I am so disappointed that you're not in high vis. I can't tell you how much it breaks my heart to see you not with the sombrero. You know, I only know you from Awesome Framers on Instagram, so I'm excited.
This close to wearing it.
Oh, it would have been so nice. Or the big intro jump would have been nice too.
Yeah, I know. That's somebody in the chat said that too. It's like, oh,
Well, tell us something else about you that we don't know from seeing you on Instagram. What are we missing? What do we not know about Tim?
zero. It's all out there. No, I was thinking about that on the way home. It's like, no, that pretty much tells the story. I did put up as my background. We made a trip up to Suntop Lookout on Monday night. So we took that photograph early Tuesday morning, about 2:30. So that's the only other thing besides the stuff you see on Instagram is anytime I can get out and shoot astro. That's where Nikki and I try to go.
And you've got another Instagram page for that. I checked that out. I was a photographer before I was a builder, so I'm kind of into that too. So thanks for sharing that. What's your handle for your photography, just so everyone knows it?
Sonic Screwdriver. It's a Doctor Who reference.
Nice. Well, I'm not a Doctor Who guy, but I am a photography guy, so I appreciate your work and thanks for sharing that. I've met Mike Guertin once at the Fine Home Building Summit last year, which was awesome. He brought in a giant dolly full of code books and then proceeded to give an excellent dissertation on what we can do better as builders, and often was quoted after saying, none of us is as smart as all of us. And I think everybody ripped that off of you, Mike. So
yeah,
what other...
I ripped it off somebody else. So.
Oh, did you really? I've been crediting that
I
to
didn't
you
come
for
up with
years
that
now, or at least since the summit. So that's at least a year. Anyway, what else can we learn about Mike Guertin? I think you're at Mike Guertin on Instagram, but what else are you?
Carpenter. I still work. I've been working all day.
What'd you do today?
I was I was building some new sawhorses and cleaning out some stuff, and I forget what else.
Were you building sawhorses for Patrick McComb? He's afflicted with a sawhorse article, so I figured there was a tie in there.
I posted a video for Patrick so he would have a little more help putting together his article on sawhorses. So yeah, anybody listening, if you've got some cool sawhorses or your favorite sawhorse, just either post it on Instagram or send Patrick McComb at Fine Home Building a photo of it, and that way he can make his head explode with all the different sawhorse designs out there for the article he's putting together.
Nothing new under the sun, except that there always is, right?
Mm-hmm.
Well, at this time in the show, I kind of end up getting to kick things off with a toast. So I'm going to raise a glass, and I was thinking about advanced framing today, not because I was framing, but because I was insulating. And I was thinking, I can't get to that because the guy that framed this didn't do it right. So it was a good opportunity for me to remember that there aren't very many things in life that you can get paid more to do less of. And I kind of think that's the essence and the beauty of advanced framing. So in honor of doing less, raise a glass. Toast.
Cheers.
Cheers.
It's back to you, Mike.
Okay, well, let's, and I will turn it over to Mike. Mike will share his screen and give us an overview of advanced framing. So anybody in the audience, if you want to start thinking about your questions, we'll get to you eventually, and let's see what Mike has to say.
Yeah, so all I need is, I don't know if you or Brian have the host controls, but just have to enable share screen sharing, and then I can share my screen.
We both do, but only Brian knows how to do it.
Okay, you did it. Okay, it looks like it's up. This should do it. Okay, yep, worked. So
Yes.
I'm not going to go nuts on this stuff. I'm just going to hit a couple of points. This all came, advanced framing actually was OVE. Probably a lot of you have already heard that or know a lot about advanced framing, optimum value engineering. It was a federal government initiative, something that actually came out of a combination of work from the NAHB Research Center and the USDA Forest Products Lab. They really were, they were fearful at the time anyway, as I understand it, that we were going to basically run out of trees. They didn't envision engineered lumber coming into the mix and that there would be almost a sustainable supply of lumber. So they thought we would be running out, so they wanted to reduce the use of lumber while still encouraging it. So the goal was to reduce the amount of wood that went into houses by 10 to 20%. And then that kind of faded away during the 80s. Then on towards the 90s is when it started getting promoted for energy efficiency, less lumber in the walls, more insulation. And then as more and more people realized that the thermal bridging had a big part in the overall energy performance of the building in general, taking, reducing the lumber reduces the thermal bridges. And since the mid to late 90s and early 2000s, a lot of the green building programs, everything from Energy Star, Leave for Homes, ICC 700, and all of the other programs have all incorporated either in whole or in part some of the requirements for using advanced framing. So a few of the resources that I go to, the APA has an advanced framing guide, and then of course the International Residential Code, the Build America program, and then Building Science Corporation, so as well as Fine Home Building and GBA. Lots of resources out there. The major elements are going with 2x6 walls rather than 2x4. Primarily going to 2x6 because when you go to a 2x6 frame, you can do 2-story tall buildings at 24 on center. You can't do that with 2x4s. You can only do 1-story with 2x4s at 24 on center. And then of course, stack framing everything, or in other words, lining everything up from the foundation all the way to the roof rafters, floors, walls, and so on. It's nothing new. This has been documented back to the mid 1800s in different books. This is just an example of one, The American Cottage Builder from 1854, where they were promoting using 2x5 studs, and that would be a full 5 stud, which is probably comparable to our 2x6s today, and going at 19.2. This was at the advent of balloon framing. And just a quick schematic of a balloon frame wall. For those of you who've done balloon framing or taken apart old buildings have noticed that everything stacks up. The studs have the joist right alongside them, sitting on a ledge or a ribbon board. The studs going all the way from the foundation sill up to the top plate of the uppermost wall. And then very infrequently are there structural headers. Often there are no headers at all in those walls. Either the sheathing helped to carry the load, or the ledger or the let-in board that holds up the floors. So you see houses framed like this with balloon framing. So there's lots of details in today's advanced framing. I'm just going to go through floors, walls, and roofs and pick off some high spots. But the nice thing about it is you don't have to buy into the whole program. You can pick and choose what you like and disregard what you don't like. First off, if you want to do full stack frame, then you really need to be looking at framing floors at 24 on center. Well, it's commonly done with open web floor trusses. You don't see it quite as much with I-joists, though occasionally that's done. But here's a little section of the code. In the IRC, we can actually pick the span for any of the lumber we want to use for our floor framing for 12 on center, 16, 19.2, and 24. So if you want to incorporate your floor systems at 24 on center using regular dimensional lumber, you can do that. And then of course, all the I-joist companies have schedules for that as well. Where you see most people looking at advanced framing is in the walls, and all the graphics that you usually see are showing walls. And it talks about reducing the number of studs in the walls by 15 to 30%. Now that's done by a combination of things, both increasing the space from 16 on center to 24, but also by yanking out a lot of the superfluous framing that doesn't do anything for us structurally between backers and corners and blocking and things like that. And then of course, by minimizing the amount of lumber that goes in the wall, we minimize that thermal bridging. But you can take advanced framing, outside the realm of just the exterior walls and energy performance. For years, going back to the late 80s, early 90s, have framed all my interior walls at 24 on center. There's a lot of pushback from framers and drywall hangers about going to 24 on center. And, it's an option. I don't think I need to spend more money than I want, or I prefer not to spend more money than I need to on framing lumber if I don't have to. So part of my inclination towards going with advanced framing is because I'm a swamp Yankee. Single top plates, this is probably the most controversial part of advanced framing. And of course, you don't have to do it, but it is allowed by code. You can go with single top plates. You just have to make sure you do stack everything above that so that you have full load bearing below it, because a double top plate does serve as sort of a miniature header between your studs. So going to single top plate is a concern if you're going to do different floor framing distances than your stud framing. Getting on to corners and backers, in the upper right corner, I've got the old balloon, or the old platform framing type of way to frame a corner, 4-stud corner or 3 studs with blocks in the middle. And the trouble with any time you create those dead cavities is usually they don't get any insulation tucked in there at the framing stage. I remember once we were framing a corner and we finished up on the job one afternoon, came back the next morning, and we heard this scratching noise because everything was quiet early in the morning before we had tools going. We opened up the wall and a crow had flown in there before we put the sheathing on. So it just goes to show we weren't stuffing any insulation in back in the 1980s. So 3-stud corners, California corners become very common, but there are other ways to do those which even reduce the lumber further by that 3rd stud that ends up getting incorporated is really just there to hold the drywall. So instead we can use just some 1x stock, or I'll use some ripped sheathing scraps from window and door openings and tack those onto my wall stud as backer for the drywall, or drywall clips, or you can use just some ladder blocking. For partition backers, where you got interior wall meeting an exterior wall, instead of boxing that out like you see in the upper right corner, what we used to call channel backers, and end up with a big hollow spot in there, just putting some 1x or a wide 2x in behind that partition location gives you the backing you need for the drywall. The solution I like the best, and Mike, I don't think you saw it when we did the Pro Home, but I like to pull any of my interior studs and the plates back, or leave them back 3/4 of an inch from the exterior walls, and then we just shoot all of the drywall straight through. So we don't cut our drywall, we run it right through that partition backer. And from my friend Myron Ferguson, who's that drywall guy and writes a lot of articles for Fine Home Building on drywall, he prefers the less lumber as possible in any corner, because he says that's where all of his cracks come from. It's not due to the drywall, it's due to the wood that's in the wall and the seasonal humidity changes that make it shrink and swell. And then all of a sudden you get the problems where the drywall screws pop through. Moving on to headers, site-built or engineered insulated headers, whether you put the foam on the inside or insulation on the inside, the outside, or in the middle, whether they're pre-engineered or site-built, those are a good way to break the thermal bridges that you can see in the scan up here. My favorite headers are skipping headers altogether. In the code section I got listed here, non-bearing walls, you don't have to put any headers in non-bearing, non-structural walls. So that'd be like the gable end walls most commonly. So you just put a flat header board in to frame out that rough opening, king studs on either side, and you're done with it. Box headers are another good way to go, especially if you're using exterior wall sheathing anyway. You can, just by using a nailing schedule and not having any breaks in that sheathing, provided you run the structural access of the sheathing horizontally and not vertically. I mean, you can go vertically or horizontally with sheathing. There are advantages to going different directions, but if you're going to do box headers, you do have to have the strength access going parallel to the header. But just by adding some extra nails to the sheathing on the outside, in many cases, you can span over most common window openings. Here's an example of that. For a 28-foot wide building, that'd be front wall to back wall, 2 stories with a roof supported by an interior wall, with a 15-inch one-sided box header, in other words, just your exterior sheathing nailed at 3 inches on center, you can get up to a 4-foot opening span. So good for most windows and doors unless you're ganging those all together. Rim joist headers, rather than dropping a header onto jack studs, you can incorporate that right into the floor framing, either as the rim joist that's already up there, be it strand board for an I-joist system, or some dimensional lumber, or maybe if you got a wide opening like this, we just added an extra LVL in there, a couple of hangers, and then it just allows us to get more insulation in that would ordinarily would be a structural header drop down onto jack studs. There's a new section in the 2015 IRC which outlines all the code requirements for those rim joist floor headers. And then lastly, on roof details, to get better energy performance. And one benefit I like about this is reducing ice dams. Photo on the left is one on a high performance home. The one on the right's an older home. And you can just see the difference. This was taken the same afternoon on the same day during after a pretty snowy winter around here. So of course, raised heel or energy heel trusses, just getting the top cord up off the bottom. And that allows you for whatever loft of insulation you want to put in there if you're going to do it conventionally, or if you're going to be doing stick framing, instead of just dropping the rafters on top of the top plate where the insulation ends up getting kind of squished down where the rafter's sitting over the top plate, you can set that rafter on top of the floor joist. It does take a little extra lumber because you're going to have to put in a rim joist, but it's a way to get a more loft of insulation in there. And is just another detail for a regular Cape style roof where you get the insulation going up through the floor system, rafters on the floor deck, and then the insulation carrying up through the roof. From a performance standpoint, the differences, and this is from an evaluation of R21 in conventionally framed walls, the whole wall performance doesn't, when you get right down to it, doesn't increase a whole tremendous amount. When you look at it from a 2x6 at 16 on center, gives you whole wall, and this is just on a case study, 16.7 is effective R value. When you go 24 on center with double top plates, it gives you an extra 0.6 in your R value, up to 17.3. And then if you go to single top plate, it's quite remarkable. Just by switching from a double to a single, you get another 0.5 on your overall effective R value. So that's probably primarily due to the thermal bridging through the studs and the walls. So I'm just going to throw the question out there. Is advanced framing even worth it? I did it for years. I thought it was a great idea, but as high performance buildings and particularly with wall framing and different wall systems have gone over the last, say, 15 years with exterior insulation and double wall studs or double stud wall framing, do you really get that much extra bang of insulation by going with advanced framing? You could probably go with 16 on center with exterior insulation, and the overall wall performance isn't going to drop that much versus an advanced frame wall. So that kind of changes the whole thinking of whether or not you want to go to advanced framing. And then if you go to double stud walls, the same thing. And then lastly, I'll leave you with this. One of the things that's come up, which just blew my mind a few years ago when people started bringing it up as a thought experiment, or actually a practice, is putting more wood in walls or in buildings in general as a way to sequester carbon. And here's just a little thing I pulled off of a USDA, US Department of Agriculture, thing about the wonders of wood in buildings, and it talked about sequestering carbon. So maybe we should just be framing our walls with cross-laminated timbers and have solid wood walls and do insulation in some other fashion, so that we can, if we build high-performance buildings and we put lots of wood in them and we make them last for several hundred years, we can sequester the carbon. So that's it. That's where I wanted to leave it. Choose your details and, pick and choose and see if it's worth it, if you think it's worth doing the advanced framing.
Thanks, Mike. That was great. You answered quite a few of my questions already, but just from a practical point of view, when you are doing single top plates, I know you mentioned that's one of the more divisive aspects of advanced framing. How do you keep your top plate straight? Like to me, the double top plate is less about strength and more about when I've framed that second top plate, basically straightens out the crooked first plate. Is that just because we get crappy lumber here in Maine because we ship it all away, or are there processes that make that not a big deal?
I haven't found a problem. I've been doing it for a while. As long as you brace it and as long as you pick your stock, it's just like doing double top plate.
Mhm.
No problem with straightening them out.
Okay, sounds good. And Tim, you frame full time for Pioneer Builders, or build full time and do a lot of framing. How often, or how much are you invested in the advanced framing approach? Are there aspects you like and aspects you don't like?
Yeah, we made the switch, I think, about 3 years ago. We switched to floors 24 on center and exterior walls, but for some reason, the first house or two, we stuck with 16 on center inside. And we were like, what are we doing? So we're all 24 on center. Our roofs here in the Pacific Northwest, truss roofs, rafters have always pretty much been 24 on center. We're not doing the single top plate, but I was just thinking as you asked that question of Mike, if I was to make the switch, I think I would do a single top plate out of like LSL because it's so straight and it's a little stiffer. So, because I've been resistant to the single top plate for a while, just because it's a little, we're trying to go fast and we try to do a minimal amount of bracing. But I would be interested in talking to my brother about doing one of these if the engineer signs off. And for us, LSL is about double the cost of dimensional Doug fir. So if we use half the sticks at twice the cost, it would just net even. And I kind of like that idea. Then I could actually order those up to like 30-foot lengths. So I could order per wall.
Yeah, I've done it that way just for the same reason you're talking about. You get it nice and straight, it's stiffer, and we've been able to get them up to 40 feet. So, typically what do you get for dimensional lumber when you're doing conventional for top and bottom plates?
I'm usually ordering 16s or 20s, Mike. I can get 24-foot 2x6 pretty easily. But then for certain tall walls, I'll order 30-foot LSL anyway. So I'm going to talk to you. So this was I learned one thing. You got my mind going. That's great. I think I want to try that on the next one.
Yeah. Yeah. So what are other typical arguments against advanced framing? I mean, I've heard a lot of people concerned about the vertical loads. They're afraid that 24 on center won't support the vertical loads. Is that a concern at all for you guys, or no, not really?
Nah. In our case, our engineer, we're doing the single header. He specified 1 3/4 by like 7.5 LVL for all of our headers. We'll probably go up to 9.5 just because that's our window height. But he works with us. The local building department works with us. There's just as long as I do the layout right, that's the kicker, right? As long as everything stacks, then there's really no issues. Load pass, trace, and we're good.
Yeah. One of the big pushbacks I've heard is from the finish carpenters, trim carpenters, especially on exterior walls that are non-bearing, where you just got king studs on either side. And they always want a little more lumber on either side of the wall in order to install the trim around windows. And the same thing with 24 on center. People doing crown molding, they like the 16 on center, so they get a little concerned about not having as much stuff to nail into. But what I haven't found with doing my own trim work that's been a problem. So
I think
it's only a problem when it's really, really wavy. If you have flat ceilings and straight walls, then you don't need as much nailing because you're not overcoming those bows and bellies. So it all starts with kind of what Tim was saying, the idea of making things straight. If you're running LSL plate, I don't see a downside. I mean, that's a real win, especially when you save all that time stringing and pulling things back in and out. Man, what a benefit.
The pushback that I see a lot of, I like to use dense packed cellulose. And so the sheetrockers, you touched on this, the sheetrockers kind of complain a little bit about that because dense pack has a tendency to pillow out if it's actually dense. So are you using 5/8 inch drywall then to compensate for that? Or are you still using 1/2 inch and telling them to roll it and suck it up?
So how do you have your insulators do the dense pack? What are they putting a scrim over the studs, or are they putting panels and blowing behind a panel, or do you blow after the drywall goes up?
They definitely don't blow after the drywall goes up. Usually they insul web and blow, and then they cover it with the drywall. So depending on, I say that I have a project that is a community project, and they have a pretty slick setup where they have a board and there's holes in each of the board, and it keeps it really solid. And so because the homeowners and the job captain actually dense pack their own walls, and so they've kind of figured it out, the system. But I would say on average, more of the dense packers, depending on who you get, people who have been doing it for a long time have a system. If you're getting a big insulation company who does some cellulose but mostly something else, they're just, they're stapling the insul web up and they're dense packing it, or hopefully they're dense packing it. I go through and do a lot of inspections to see what's in there. But then if they really have like large areas where it blows out and it's 24 inches on center, that has been a pushback and an issue, and any force on that moving towards doing 5/8 inch sheetrock instead to kind of cover some of those issues. But
Yeah, I know exactly what you mean. I've because with the 24 on center, if they're just blowing behind a sheet, then it does pillow out, and then you have to take a roller and press it back in. Or what ends up happening is they don't want it to bulge out, so they don't actually pack it as dense as we really want it. What I resolved myself to doing is actually doing my own dense pack. So I just get the machine and I do just as you said your insulator did, where they take a panel and put it over it. So I just have a sheet of 3/4. We put a couple of screws in it. We have some holes in it. We blow it behind there, and when we take it down, it's good and straight. But changing an insulating subcontractors practices to move them in that direction might be a big ask. So
we moved to basically just using people who do dense pack as a rule of thumb. They don't do other things, and so it's kind of resolved a lot of those issues. We also do a lot of double stud walls, so it's not it's not as big of an issue because now they're dense packing an even larger cavity. So it's more than the traditional, dense packing the 2x6. But when we were dense packing the 2x6, that was an issue that we ran into with certain insulation contractors.
Yeah. Oh,
Brian's muted.
Brian, you're muted. Yeah.
Mike, do you own that machine or do you rent it?
I share it with a few friends. So a friend of mine bought it, and then I trade some of my tools. He borrows my tools when he needs them. I borrow his tools. So it's kind of a wash for both of us. So
is it the same machine that you would, for dense pack, is it the same machine that you would rent to blow cellulose into an attic, for example?
Well, it's what I would want to rent, but it's not one you're going to find at the big box store. No, this is a professional machine.
Okay.
Yep, it's good. You can't use those lightweight machines. Won't do a dense pack. They'll blow loose fill, but they won't be able. They don't have the blower isn't powerful enough to dense packs. So.
And I also was curious in your presentation you mentioned not needing headers in non-load bearing walls, which struck me as kind of obvious. And I'm curious, is that not obvious? And are some builders putting headers in non-load bearing walls?
It's extremely common in our market. We
It is.
have framers that are generally working by the foot, cost per foot. They're working as fast as possible. So any deviation from what they are typically seeing is slower for them. So they would rather waste the time to cut cripples and jacks and throw in a header where we don't need it, because it's the exact same thing on every opening. Inside, outside, they don't have to think about load path. They don't have to look up and go, oh, the joists are running the same way as this wall. I don't need it. They just want to move fast. And they're typically a separate thing from the lumber package. So, you know, some guys are turnkey, but a lot of these framers they're just framing. They don't care about the lumber cost. So they don't have the savings in mind, like Mike Guertin was talking about. There's no money in their pocket unless they go fast. So any change at all is a big deal for them. I actually framing an addition right now, and I introduced my framer to the concept of the 3-stud corner. I felt like it was a real victory for the world. Like, you know, this is not groundbreaking, but you know, some guys, you just have to bring them along. And I think that we can get there. I would love to see more box headers, like Mike's saying, and definitely I've never understood why we can't just go ahead and double the rim joist if we need to, and then eliminate all the headers, because you have that floor diaphragm. There's plenty of room for insulation in there. And then because we do mostly remodeling, it solves a litany of problems down the line. You can move things. Oh, I want a bigger window. Great, no problem. We've got, you know, double 11 7/8, 1 3/4 LVL in that. Let's go ahead and mount that deck to it also. It carries so many problems are solved that way. But you do have to have someone who wants to spend a little bit more on the material on the front end and slow the framer down and really only do what's needed. And I really wanted Tim to speak to that, because I know that at least in the Instagram videos, it looks like you guys are flying. Do you guys have to slow down and chase these detail down, or is it's part of what you're doing already?
So all of our Instagram stuff is time lapse, which makes us look really fast. So that might as well be Hollywood. Yes, we do have to slow down. It hasn't, which is like, it is against the grain as a framer. You know, everything you're taught to do is to try and get into a rhythm and consolidate steps. And if you're already cutting headers, it's faster to cut more headers and cripples and just keep rolling. But we're also in-house framers. You know, we're a family company, so we have the luxury of slowing down and trying this stuff out. I kind of like the idea of, I'm very resistant to things like hangers, because when I started, it was my job to hand nail hangers. But now we use guns for that stuff, and it goes really fast. And a lot of times I would rather just nail on hangers all day and just turn my brain off than actually have to. So I kind of like the idea of like the rim being perpendicular, of just hangering it all. It doesn't take that long, the gun, especially 24 on center. Hanging all your joists, not having a difference in thickness of rim, but just make it all 1 3/4 LVL. And then my mom especially loves to come in and add windows after the fact. And they're always 3 stories up when the wall's fully sheathed. I mean, it is like, our joke is we're the fastest new construction remodelers west of the Mississippi, because we can put a hole in a wall so fast. But that would even, you know, make that. So I can see what you're saying. There's a lot of advantages even down the road. And if we got into a rhythm with hangers, then you don't really have to worry about headers. Use up all your scrap 2x6 for the flat header, like Mike was showing. So you guys we already do half of this stuff, and you're kind of making me think, why don't we just, you know, take that next step and do the other half?
One of my pet peeves is sill cripples. I don't see any functional use for a cripple under the sill, other than it makes it a little easier to knock the buck together when you're framing. But I've convinced builders of some things, but I've never been able to convince anybody to skip the cripple. Do you guys include the cripples? Do you think it's important? Is that something that could be eliminated?
Eliminate it.
Yeah, it's not.
Get rid of it.
Yeah,
I think if it's under 24, I should actually go through, Mike. My brother said, make sure that you tell everybody on the panel how we just failed an inspection, drywall inspection, because one stud in this house was at 25.5 inches.
Checked it? The inspector
Good
checked
old,
it?
and so this inspector, we go way back. He's retired now, but he's he's doing contract work, and we just love this guy. Only Greg would catch that. So Kyle was heading out there this afternoon to put it in. So it was like, yeah, we got so advanced that we didn't even follow the instructions. The cripples under 24 inches, the drywallers aren't even screwing their drywall to it anyway. So I'll walk through and go, well, what are we putting them there for? For an outlet box maybe? So I think on this next one, we're going to just really look at a lot of that stuff and get rid of, we already leave off the ones that are up against the trimmers or the jack studs. They don't do any good. We're fully sheathing our walls. We're single sill. What's the point of that? Sometimes our windows have one cripple. Like, what's the point? And then when the drywaller doesn't screw to it or fasten to it, you're just like, that was a waste of everybody's time.
Of course, the trim carpenters, when they ran on their baseboard, that's, you know, an 8-inch baseboard, they're the only ones that would complain about that.
We're long gone. No, our fence carpenter.
That's the way framers always approach it.
We're long gone. Yeah, so when we made the switch, that was one of our big things was, okay, what is the finish carpenter going to say when he's hanging cabinets? And these guys, they don't care. They glue things to the wall, they screw things together. He's like, just do your thing. And they don't push back at all. So either we just found those really easygoing finish carpenters, or maybe they're very production oriented. So if they don't have to hunt around for a stud, looking for a stud, they won't. So for us, it just hasn't been an issue.
Can I ask you guys, Mike and Tim, about wall to ceiling connections? I know the energy heel truss is a pretty easy solution, but when we're stick framing roofs, which is the majority of the market here in the Midwest, I would say, maybe I'm wrong about that, but what I see in my area, how about that? In my area, we see stick built roofs, and I'm wondering if there's a better way to, can we do a taller wall? I know obviously there's the fire blocking issue, but I was wondering about doing like a taller wall to raise that, basically to get your bird's mouth up and create that insulation space above, well, the lid, the whole point of the energy heel truss. I'm not expressing my question very clearly, I'm sorry. But the idea of, okay, I can run my zip all the way up now, I've improved my air barrier, and my roof's sitting high enough that I can actually hit the R value without depleting it at that juncture. I guess I'm trying real hard to figure out why we don't see any of that ever. I'm missing something really obvious, right, guys? What are we doing here?
So if you're framing, if they're sitting the regular conventional dimensional lumber roof rafter on top of the top plate of the wall, you're looking for a way to get it up higher. That was the one way I do it that I showed in the slides there, is you just put a rim joist for your ceiling joists and then treat those ceiling joists up against the rim joist, and then you can set the rafters on top of that. So that'll capture the actual height of your ceiling joists in your insulation layer. That's the only way I can think of to really do it without having to set a lead-in ledger and a bunch of other things. So it might make that, like you say, fire blocking a little more difficult.
So Mike, do you run a plate on top of the joists for the rafters to land on?
Usually no, because I'm too cheap and I want to skip it. So I'll just cut the bird's mouth and I'll sit it right on top of the rafter, which is also the rim joist, and then I'll just tie it with a scrap block or something. But you could put a plate on there. Tim does it a little bit different, the way they frame, because he doesn't cut bird's mouths a lot of times.
Yeah, we've been back and forth on that. If it's an I-joist roof, then we do the cant strip with a bevel plate.
Yeah.
And that is, I mean, it saves so much time with an I-joist. With the engineer, we've been back and forth in the municipality. So we're doing bird's mouth, but we do the bare minimum. To transfer load, we only really need about a 2.5-inch bird's mouth. So we'll shoot for, and if we're gang cutting, we'll shoot for about 3 inches. So we're already getting about 11 inches high, depending on the pitch of the roof. So if we want, so we're kind of a special case because the climate here is so mild. Our frost line is only 12 inches. That doing some of these extra things just for the insulation detail is really not cost effective. We can make up for that with air tightness or efficient appliances or other things. So we don't push that particular detail yet. But as Washington keeps getting stricter with the energy code, even then, I don't know that we will. We'll figure out something. If that became an issue, like we don't have ice damming or anything like that. In fact, we had somebody ask us today, we only hit under freezing like 2 or 3 times a year in our area. And that's until the sun comes up, right? So like we don't frame in the cold. We just frame in the mild and wet. So we just aren't going to spend a lot of time on that detail. If we did, I was going to say the same thing as Mike. Just frame your ceiling like you're framing a floor. And then you get that extra, whatever the depth of your ceiling joists are, there's the extra depth for your insulation.
It's also good for order order of operations. I mean, platform framing, I think, took over balloon framing because it's better from an order of operations point of view. You can build your own staging as you go. So when you frame your attic floor first, it makes it a whole lot easier to set rafters. If you're trying to set rafters without your attic floor in place, then you're pretty far up there.
Mike, you mentioned, you said something in your presentation about stories, a number of stories in advanced framing, and someone had asked, right around the same time, someone had asked a question if how many stories you can go with advanced framing techniques, if there's a limit on that, you know, if you have your loads stacked properly.
So if you're following the IRC, then, and you can only use 2x6s for 2 stories at 24 inches on center. So your first floor and your second floor. I end up building a lot of houses that are 2-story houses, but because of the slope in the grades, we end up with a lower level, basically walkout basement. So that's our 3rd level. So we have to prescriptively drop to 16 on center, unless we have an engineer involved. The way the IRC is written, as far as the wall framing, it does not presume that we're putting structural sheathing on the outside, which is why we have the limit to a 16 on center for that lowest floor on a 3-floor or 4-floor house. You need the lower 2 floors. When I have an engineer involved, because we're putting structural sheathing on the exterior walls to meet our wind resistance, and Tim's doing it for seismic out there, that sheathing will reinforce the studs. So then the engineer will allow me to go 24 on center for 3 or 4 floors. So it's one of those areas where the IRC makes some presumptions that we can't get around unless we have an engineer involved.
Okay. So I brought up Trevor when we were talking about the roof rafters and rafter to wall connections. He was in the chat making what I thought were some interesting points that I couldn't convey. So I just thought I'd ask him to come in and maybe share that with us.
Yeah, this might be something that's kind of like Travis said, kind of maybe unique to Kansas City and maybe a few other places. But we build a lot of our roofs stick built. And if you're going to do that, there's just load path issues you got to think about, because the rafter comes down and it's got an axial load in it, and then that's resolved back by the ceiling joist. And so if you're going to do anything weird with that rafter, like maybe lift it up to give yourself a heel, then that axial load doesn't have anywhere to go. It needs to get pulled back and resolved on the other side of the roof somehow. So you could do that with kind of like in a truss. You could add a diagonal member that would pull it back into the ceiling joist, or you could add ridge beams, which take the axial load completely out of it. It just gets a little tricky. So if you're gonna stick build a roof and you want to mess with the traditional way of doing it, you gotta think about it.
The ridge beam is the move for sure. We're seeing so many local jurisdictions that are requiring that anyway, which is so frustrating to me because these jurisdictions are not structural engineers like my good friend Trevor. They do not really have the knowledge base to make that requirement. But since they're going to require it anyway, why don't I just go ahead and do that? And then I don't need that member intention to keep my gable from spreading out and the exterior walls blowing out because I don't have my ceiling joists in the right plane. So that's a great solution. And of course, Trevor comes on and doesn't make me feel like an idiot for fixing my structural failure that I've designed in my head. Thanks, buddy.
Yeah, I see a lot of people mess that one up or just not realize what's going on. And so it's a common thing I see here in Kansas City. So.
Cool.
Thanks, Trevor.
Yep.
Thanks, Trevor.
No problem.
Yeah, there's a good question. Are there any issues with using 2-inch zip R sheathing and 24-inch stud spacing? I know Mike's a zip R expert. Well, at least I've asked Mike a bunch of zip R questions. I phrase it like that. Are there any issues running zip R 24 on center you're aware of, or is it that's what it's rated for?
I'd have to pull the instructions up. The only thing I know, it shouldn't be an issue until you get into seismic and wind loaded areas.
Right.
And in that case is where zip R has to be installed in a certain way with the nailing pattern. Like you're going to need, I think it's 4-inch nails at 3 inches on center or something like that, at least around where I am in 120-mile-an-hour wind zone with the R12. So it ends up being a little bit more difficult in it, but I don't know about the 24 on center. For most of the country, it probably won't be a problem. It's going to be in seismic zones and high wind zones where those will become issues.
Sure.
Our just on the 24 on center framing and the shear walls, we have the same number of total nails. Your edge nailing doesn't change. And so normally for us, we're at 6 inches around panel edges and 12 inches in the field. But as soon as we go to 24-inch on center, we're at 6 inches on the stud. So it's the same number of nails, just on one stud. It's like a footnote in the EPA, and then the engineer says. So I would be curious to see, depending on the house here, because our engineers had some reservations. He wants to talk to the Huber engineers, but he's like, totally, let's do it. Let's just talk about it. He might just tighten up the nailing or require a thicker shank nail, like a 148 instead of the 131s that we shoot through sheeting.
Yeah, and Steve Bazek is in the audience. He says for zip R, he found shear can work in general, except for uplift. Yeah, that makes sense. So I think when I first learned about advanced framing, one of the big things was to plan your design so your windows fit within the 2-foot layouts, and it seems like that's very limiting on a design end, and I haven't seen anybody actually try to implement that. Have you guys seen or done or included that, like worrying about your layout, whether it's by feet or inches? Would you ever shift the window over a few inches if it saves the stud?
I do it all the time, and then I don't tell anybody.
Yeah.
We'll see if they pick it up.
Don't tell your architects that. Yeah, they won't.
Yeah.
Hey, Mike, I changed a whole bunch of the windows in the Pro Home.
Oh, I know.
I moved studs, I moved windows all over. Just so I could save a stud here and a stud there.
That's okay. That's good. What else do we have for audience questions?
We've been knocking them down without even asking them, because the same kind of things have been coming up that we've been asking as our audience has been asking. I did have a question about, and I'm not sure I understand what the intent of the question is, but I'll ask it. Maybe Mike and Tim will get it. But one question was, what do you do for tall walls, and for example, with a stairwell on an exterior wall?
Engineered wood.
Yep. I was waiting for you to say it, but
Yeah.
Those LSL studs are just like dream come true. Yeah.
So you guys, it sounds like you both use them selectively throughout a build based on where you need and where they make the most sense.
Mm-hmm. Yep.
Yeah.
Yeah, especially for us, we're trying to, I know it gets a little outside the scope of this, but we're trying to frame walls as tall as we can and do as much to those walls as we can before we lift them, because we don't want to get on ladders. And with Instagram, we get a lot of attention from the safety police, not just the Instagrammers, but the local safety guys. And so we're trying to do whatever we can to eliminate the need for fall protection. So we've got, we had the dirt guys out there today. Just the timing worked out because we didn't have forklift access. And so now we'll be able to side the 3rd-story walls, all of them, before we lift them. So that's where the LSL comes in, is like, I can order up to 24-foot Doug fir. I've done it. They were actually pretty straight and flat. And we can do some work to them as we're framing interior walls to kind of plane them out. But there's no extra work with the LSL. I just pick the tallest stud and I order the studs until we get to like, maybe 16 to 20 feet might be the cutoff depending on where it's at. But anything above 16 foot, I might go LSL, but generally it's anything over 20 feet. The advantage to us is that it's straight, and then it's nice and stiff when it goes up. and then we're done. It's just fast. But we're choosy because they're double the cost of sawn lumber. So it doesn't make any sense to us. The thing I always tell people who are on the fence about 24 on center is if I took you through 10 of our houses and had you write down which ones you thought were 16 on center and which on 20, I guarantee no one would get it. And then at the end, I would reveal that they were all 24 on center, just to fool them. You just can't tell, because there's guys that don't crown studs on 16 centers and their walls look awful. And, so just be choosy with your material.
So I also wanted to, Mike, I wanted to ask you, you mentioned, you showed sort of the modeling for whole wall R values with different scenarios, and then asked the question, like, is it worth it? And I think is advanced framing worth it? I guess you were saying that from an energy perspective, and the fact that we're doing a lot of different things now to get to higher whole wall R values. So I'm curious, since you've done a lot of different things, if you have now a preferred method for a thermally broken wall.
For me, it's just been exterior insulation.
Yeah.
It just makes it. I haven't had a problem with doing it. Some people don't like to do it for a couple different reasons. Hanging siding can be a little bit more tricky and things like that. But that's the way I've done it. I know other people have done the double wall studs, but I haven't been able to convince myself yet that makes sense for me.
Mm.
Yeah, the thermally break is just exterior insulation. It just makes a whole lot of sense, one way or the other. Double wall studs or thicker walls, or thermally break it that way, or by doing the exterior insulation.
Sure. Cool.
The exterior insulation is such a win on so many levels. I know I'm going to be in the minority here, Mike. Emily, go ahead and just burn me down now. Your double stud loyalty is well established, but my single wall in the Midwest is performing well for climate zone 4. And if we're handling our insulation at the exterior, it really does minimize the importance of a lot of these details if we mess something up at the framing end. I guess I don't want to suggest that we should just use more wood, but it makes it easier for guys like me that are working with maybe 3 or 4 different framers in a year, and this framer can't get to it. So I go to my second choice framer, who's also busy, to my third choice framer, who I have to retrain every job. He doesn't hit these details every time. So if I can just get him to at least give me the 3 stud corner, I can solve the headers on the inside, and I can maybe do some outsolation here and there. That sort of resolves some of this. It's just, I guess every different avenue has its benefits, but that certainly is something that if we could go ahead and get the code enforcement to jump on actually requiring what's already in the energy code, then maybe we could solve a lot of the problems in my market.
Yeah, well, I think in New England we'll see a shift from double stud to exterior insulation as the quality of cellulose insulation declines, because they're not making as many newspapers, and more importantly, as locally made wood fiber rigid insulation comes online. Just a lot of us are trying to do low carbon petroleum free homes as much as possible, and so foam works well, but it has climate downsides and potential health downsides, potential flammability downsides. Mineral wool is a little better, but it's still relatively high carbon. So once we have super low carbon, locally sourced wood fiber, I think we're going to see a mass shift from double stud being the local favorite to exterior insulation. That's a guess. What do you think, Emily?
Well, I think the other thing that you didn't point out, which you usually point out to me, which I love, #BuildingScienceMike, is that up here in this climate, we can't always get away with an inch or 2 on the exterior. Like sometimes, depending on the material that you're using, you need 3 or 4 inches. And when you start getting out to 3 or 4 inches, it gets a little bit more complicated, because now the siding that you're hanging off of it is a lot farther away from something that's more dimensionally stable. So the pushback that we get on that often is the details of a heavier material being kind of outside of a significant amount of exterior insulation. Because correct me if I'm wrong, Mike, it's something like 30% of it has to be outside of your sheathing. And if you especially where we're aiming for a more passive house level or a net zero level. Like my double stud wall is 9.25 inches thick. If I'm at 9.25 inches thick, I got 4 inches outside of my sheathing, and that all of a sudden starts to add a couple of additional details that have to go onto it. And the other pushback is, if you're not going to a window that's inset in a wall system and you want to put in a flange window and then you've got trim, etc., sometimes it's more cost effective to build an extra stud wall on the inside because everybody knows how to do that than to figure out all the details and the trimming around 2 to 4 inches of insulation on the outside. So that's usually what I find is sometimes it's just a knowledge base, like, a double stud wall with a flange window on the outside of the double stud wall isn't that big of a deal. But a, inset window, all of a sudden it doesn't make as much of a difference whether you have insulation on the outside or the inside. So.
No, that's a good point.
Emily, can I ask you another question? What does advanced framing look like from your point of view when you're designing a house? And how much are you thinking about, how much do you need to think about that? How much are you thinking about that? Obviously, just where you land your windows, right, if you're really thinking about advanced framing, that'll be part of your design process. So I'm curious what it looks like for the architect.
Yeah, if you're really trying to do advanced framing, you want to do it from the very beginning because it's so much easier if your windows align with your advanced framing, if you know that your floor framing aligns with it. And then you during the design phase, that allows you to kind of move your plumbing so it doesn't fall on top of a stud, or your window so that it falls in line with that. And going down to a single header changes the amount of head height you have. So sometimes we do double top and bottom plates to get 8'3" instead of 8 foot because studs come in 8-foot sections. So sometimes during the design, advanced framing doesn't work out because we're trying to get something else out of it. But as far as efficiency goes, the more we can plan for that, the more accurate our dimensions are, and things should line up more accurately, more correctly. The longer I'm in the field, the more I want to know in the drawing set while we're doing it than figure out in the field, if I can. So it doesn't always happen, and it depends sometimes on the builder, the person that you're working with. But if I know where all of that stuff lands, then I can plan for it, and then we can reduce framing because we've been smart and our windows aren't in between every stud. They're more accurately positioned, and pulling the headers up into the rim joist allows us to have taller windows, and everybody wants taller windows. So there are some things that lend to good design that happen by knowing what that is during the design process.
Good answer. Mike, so Tim, you're also you're all in house. So your company has made the shift together. But Mike, I'm curious about your work shifting to advanced framing. Were the designers and architects on board and moving you towards advanced framing, or was it the other way around?
It was the other way around. Rick Arnold and I started doing it when we had framing crews back in the early 90s. We were framing production homes, sort of. Well, it was track home more than a production home. We were framing in it for a builder and doing one house after another, after another. And we kind of made a handshake arrangement with the builder that if we could reduce the amount of wood that went into the buildings one way or another, and still keeping structural integrity, that we'd split the savings. So if we could peel, $300 or $400 out of a building, which in the early 90s was, about maybe 5% of the cost, or 5% of our bid or something, we were able to put that in our pocket. So we did it.
I think it's important to not lose track of I realize the cost on the front end is great. Using less wood is good for saving money for the project, and generally speaking, it should be less work for your framer to cut less members and nail less members. Although Tim made the great point that you have to pay more attention. You have to know what to do in the right places. So there is some slowdown there. But the long-term benefit for the home, which generally we should be designing and planning for 100 years, right? We're trying to leave these houses. The built environment is supposed to be this durable item that is going to require energy to condition it to the occupant for its entire life. So the cost of the stud that goes in, I guess I wish it wouldn't be the first consideration. And I don't think it is from you guys. I'm not suggesting that. I'm complaining about my market as usual. Sorry. But the gist of it is that we shouldn't be looking at it in such a short-sighted, like this moment in time, we saved this money on material and we saved this money on labor, maybe, or it was the same, or maybe it was more because the framer wasn't familiar with it and he really had to slow down to get it right. And all those things are important, but if we're being responsible with our work and we're looking at it in terms of the occupants for a longer term, then it's always a win, right?
Well,
Yes, Travis.
Yes, Travis.
Thanks, Tim.
You're welcome.
Long pause
I
of
got you.
foolishness.
I got you. So I had an interesting conversation with a Weyerhaeuser rep locally, and he says he goes out on field calls nonstop because the subfloor is buckled on the floor. And of course, it's because the framers didn't gap their sheeting. And I asked him, I was like, well, that was like pounded into my head 25 years, 30 years ago. What he said, like in our area, we have a lot of crews that portions of them will leave the country for a period of time and then come back. So the amount of turnover on those crews, that knowledge isn't getting passed down. So like everything that I hear you guys talk about, or Fine Home Building Podcast or whoever, Unbuild It Podcast, it's not translated to the guys in the field, some of whom may not speak English. And they're hard workers, but that's not been translated to them. There's no formal training for us as framers. So you're trying to take somebody who's there to do things as fast as possible, who thinks that the guy that taught him was the world's best framer and therefore he's the best framer. Oh, is Steve Basic really coming on? Might be time for me to leave. Just kidding. So I think that's a big part of it, is that you go, okay, let's introduce just a couple new things. A 3-stud corner, which we were taught in the 80s in Washington. And you're just like, really? This is new to some people? Well, it is, because that knowledge isn't passed along. Instagram has been good. JLC Fine Home Building's good. But still, as long as framers, there's no barrier to entry, just don't know that a lot of the stuff is gonna take off the way that we'd like it to.
That's fair. I wanted to bring Steve on specifically so that he could give you trouble, Tim, but also because he works with a variety of different builders as well. I would think a high variety. Whereas with Tim doing so much in-house and Mike doing so much of his in-house, I assume you're very rapidly assimilating knowledge and everyone's on the same page very quickly. You bring people up. The keeping craft alive is happening on your crews. So with Steve going from site to site and obviously he's dealing with mostly high-end builders who would hire a quality architect, but still I assumed that he had some input on bringing people on board to these details, because I feel like that's the stumbling block. If you can get guys to adopt it, then they can take it and run with it. And I guess you alluded to that too, Tim. So maybe we're just going to reiterate the same point, but anytime you can get Steve on, it's good to cause trouble, right? Are you there, Steve?
I like your point, Travis, that Steve gets to work with a lot of high-end builders who just settled for the cheapest architect they could find, Steve.
Hey, how's the second sexiest man in the building industry doing?
I was really hoping he was going to back me up and say that everything should just be on the drawings because that's the cheapest time to figure it out.
Everything should be on the drawings. I would agree with that wholeheartedly.
As long as the lines are straight, Steve.
As long as the lines are straight and the person drawing the lines knows what they're talking about. Right? It's not
I would
Mr.
never tease an architect the way I tease you.
That's all right. That's all right. I'm a big boy. I can take it. I've had a lot worse than you come along.
I'm sure.
So Steve, how do you get over that hurdle? How do you get these guys to do exactly what, is it literally as simple as put it on the drawings and then they do it? Because that's not what I see in my
I don't think it's that simple. I think the first step is that, I develop drawings with an initial intent, and let's say we get them to 30% of the way. most of my projects, I'm very fortunate that I either pursue the homeowner to get a builder online, or the project started with a builder online. And either way, when we get those drawings to kind of 30%ish, you know, where we have a good understanding of what we're doing, then we have the conversation of what kind of sheathing, what kind of details as far as advanced framing. And I'd love to tell you that there's kind of a set recipe, but it's nowhere near that. I think every project of mine, it's sometimes we do this, sometimes we do that. Some builders buy into a single top plate. Some builders say, hell no, we won't. And, you know, you live with whatever. You know, 24-inch floor frames, while I appreciate them, those are usually a big challenge. You know, a lot of times we just stay with the 16-inch.
Is that to get head height? Or are you trying to keep ceilings or the
No,
diaphragm?
it's, I mean, a lot of the newer houses, you know, nobody builds a 12 by 16 family room anymore, right? So you're building a 22 by 26, 28-foot family room, and you want to put a master suite above it. So you're either putting in, you know, a whole bunch of LVLs or a steel beam or something. So it becomes a little bit of a challenge. And so in that case, I mean, I don't know if you saw it. You probably did, but if the others, I did that. I'm doing a big house right now. I mean, hell, we got every kind of floor system in that. I got double 16s on 16 inches on center, single 16s on 16-inch on center, 16-inch floor joist at 12 inches on center. I mean, it's just different conditions in the house push the floor joist all around. And the builder was really good. I mean, you know, having that meeting and having the intent and the understanding by the whole team. I mean, Tim has the privilege of him and Brian kind of, you know, Brian being the client, Tim being the framer. They can kind of say, okay, we're going to do this. And it probably changes sometimes, but their changes, oh, we're going to do it like the Joneses, not the Smith's house. And they do it like that. I know I'm speaking for you, Tim, but.
You sound better when you speak for me, so go for it. You sound way better than me. Yeah, to the comment, and I appreciate what Steve's saying. We're fortunate because we're in-house framing and siding and the concrete work. And our designer we've worked with since Dad started in like the late 70s. I think he started working with Jay probably in the early 80s. And now our engineer is that preliminary drawings can go back and forth. So the designer has this idea, everybody likes the layout, then the engineer can weigh in and say, but if you changed this, it would make everybody's life simple. So the collaboration, I think you just said that, Steve, and then in the comments, that has to be there. And then everybody's life gets simpler.
That's Emily, always advocating for integrated design.
I mean, that is certainly the best way. I mean, I tell clients, I've been doing this for almost 30 years. If you ask me the 5 most successful projects, it's the one we had the builder on day one. And it wasn't, and they were still driven by budget. You just have a very successful builder that knows what they're doing. And you say, hey, we have a budget of 600K. We want to do this. Can we do that? The builder says yes. And then you just control the budget through the whole design process. When they start getting out of whack, you say, yeah, that masonry fireplace that you just showed me a picture of, that's 60K. We're probably not putting that in the project. All right.
I also find when the builder is on board day one, everybody on the whole team knows what's most important in the project. And that is really helpful, you know, whether it's cutting down on framing so they can use something else or the insulation quality that comes with advanced framing. It just makes a better project for everybody.
Yeah. I mean, everybody buys into the intent and they understand. It makes the architect's job easier, actually, because the builder knows and understands what the intent is. The guy that comes in and wins it from 3 other builders because he's the lowest price, he doesn't really give a damn what your intent is. His goal is to build it for the price he told you he was going to build it for, and hopefully quicker.
So Helen, I think her name is, in the chat says, but why bother with advanced framing for McMansions? The concept is wrong, and you end up with a bunch of steel and point loads all over. So assuming that none of us want to build what I think of as a McMansion, but at the same time, I wonder if what she's asking or what she's suggesting is that maybe there's a point where houses gets to such a complexity of design that advanced framing starts to fall down. Does that make sense?
You guys want to take a crack, or?
I'll jump in. I feel pretty strongly that when you get to a certain amount of square footage for a low volume occupancy, you have moved away from responsibility. I think there's a reasonable amount of space that people need. I know I'll get cheers from Emily on that, and Mike. We talk about this a lot. It's reasonable to have a small house. Pretty Good House movement from our friends in the Northeast talks about this at length. There's no eye to efficiency at 6,000 square feet, right? Or I guess whatever your number is, or how many people in your family. So at that point, you don't care about how much you've already shown. You don't care about how much wood you're using. You don't care how much energy you're going to use, because you want to have a 28-foot high foyer that's 18 by 24 and will have your 2 love seats in it. And I get it. It's a really pretty space. It looks great on Instagram. But it doesn't check the other boxes, and it's not something that I feel responsible about building. And I'm sure that I just lost 60 clients, but such is life.
Yeah, well, I mean, as designers and architects, we have some influence over the process, but clients want what they want. So maybe we can talk them down 20%, or if we're good enough, we can get the square footage down 20%. But it's if their requirements lead to a big house, it's going to be a big house. And so if the house is twice as big as a Pretty Good House might be, or three times as big, and you can still, Mike's numbers were something like reducing your framing by 20%. If you go with advanced framing, then if your house is 3 times as big, then you're actually clients likely don't care about the energy savings, but you'll know you're doing the right thing by doing the best you can do. You're building efficiently, and efficiently not just meaning fast or cost effectively. You're just not being wasteful. So I'd argue that yes, we should all be trying to build smaller houses, but they should still be good houses. And part of a good house is to not have studs 6 inches on center. So you just do what you need to do.
Yeah, I guess it goes back to what's the definition of McMansion, because McMansion just makes me think like worse than code, terrible, just as cheap as you can build it. If we're talking square footage wise, I think a carefully planned square footage, I think Mike was shaking his head to this, carefully planned square footage can still be done with advanced framing. You just pay attention to how you're doing it.
Well, you could do it with I'm doing a 7,000 square foot house now. That's an advanced frame. So, you can certainly put it in. And this will be interesting to hear Tim and Mr. Guertin's comments to it. But when I was at a couple things, never sell energy efficiency of the advanced framing, sell the durability of it, the health, the comfort, and all of that stuff. Because I get energy efficiency as a byproduct. Nobody buys it because of energy efficiency. So I sell it as a durable thing. So this is kind of contrary to a lot of people's belief out there that the less I fasten drywall to the framing members, the more durable my drywall system becomes, because drywall doesn't want to move, and the framing below it wants to move a lot. So when the guy's sitting there machine gunning drywall into a solid header, and that header expands, it's going to take the drywall and it's going to crack. When I was at Building Science Corporation, we worked with a builder out in Chicago, and they had massive drywall cracking, durability problems, and such. And that's Chewbacca in the background, by the way. But we actually worked with them, moved to advanced framing, lessened the amount of attachment, and saved them, I think it was on average something like $1,500 or $2,000 a house worth of callbacks, because they weren't experiencing the drywall cracking anymore. And so it can be sold as, and I say sold as like, it's not trickery, but I think if you really understand advanced framing, that one, you don't need it, so why waste all that wood? And all that wood is going to create more of a problem for you then the less wood will. I mean, we did probably the most strictest advanced framing I ever did. We did this house in Carbondale, Colorado as a demonstration project. And I wish I had a picture I could throw up on the screen, but when you looked at the walls, there was literally nothing in the wall. It was header hangers and, you know, just the studs and no jacks. And it was crazy stripped. But the house performed exceptional. And so, you know, Tim, because you guys have been doing this for a long time, I mean, do you have a lot of problems with drywall cracking and stuff like that with 24 inches on center, or does it kind of non-existent?
No. If you saw on Brian's post, we had the one where the hangers, but they lined up their seam with a 6x6 column that shrunk a little bit, so it telegraphed. That's pretty rare. We're not having any issues with drywall cracking and things like that.
Right.
We're also very forgiving climate. We just don't have those giant swings in temperature and things like that. So,
right. How about you, Mike? What do you think?
I haven't seen any problems with drywall or any other building elements due to going with the advanced framing. In fact, I think it's even less than what we used to find when we were just slamming double 2x12s up against the top plate as headers, and the shrinkage and, you know, wood changes we used to get.
Yeah, most of the cracks I've seen are above windows where you get 2x12 headers that shrink, and the headers probably only need to be, you know, 2x6s or maybe not at all. So if you do the structural rim joist and just skip the header altogether, you eliminate that whole place for cracking.
Yeah. But I think you sell it as a durability model, not as something where, hey, if you do advanced framing, we're going to save you, you know, $60 a year in your energy bill. Someone that's building a 7,000 square foot house, guess what's furthest from their mind? Saving $60 on their electric bill a year.
Oh, I don't even find when I have discussions with clients when I'm building a house, I don't even mention what we're doing. We just don't say we're doing advanced framing. It's just, here's a house we build. And it doesn't even come up as an issue, so we don't have to sell it or anything.
I would say one thing too, since you mentioned that, Mike, we consistently have customers, real estate agents, homeowners, and inspectors that feel like our houses are more solid. And I don't think they have any idea that they don't really look and realize we're framing 24 on center. So I think it just kind of speaks to the fact that when your floor is correctly sized, you're not feeling bounce. And, you know, since we're hand cutting our roofs, there's kind of this substantial quality that you perceive. And then a lot of times, just to make life easier, instead of like the house that we're doing, the garage header is like a 20-foot, 5.5 by 12 PSL. I was telling Kyle today, I was like, why don't we run it through and butt the other wall and eliminate a couple of hangers when we do it this time? So I think it's some of those little things that when people walk around, and then if you walk to the house that's 3 doors down, they can feel it. So now Brian tries to have the real estate agents come out, walk through the 2 houses. And now you're able to set this is why our house is more expensive. We're not finding really any savings in terms of labor or even materials by the time it's done. Our floors frame a little faster. You have less blocking at 24 on center than 16, so that goes a little faster, which kind of feels like a luxury. But beyond that, I'm not really seeing that our lumber costs in houses that we've switched have, that's not it. It's just, but when we tell people, why put extra wood in the wall if it's not needed? They understand that concept of waste, but it's not really saving them money, energy, and it's not saving us that much time. It just feels responsible.
Yeah, I mean, I just tell people it's the right way to do it. And I agree with you, Tim, and Mike, you know, when you say you just do things that way, a lot of people that come to me for houses and such, it's just, hey, this is how we're going to do it. And they're coming to me for my opinion. They're not trying to, you know, wag the dog. They're just saying, yeah, okay, if that's what you think, then that's what we should do. So when we do it.
So I know it's almost time to close, but I wanted to bring Armando on for the last few moments. For anyone
That's
who
no
doesn't,
good.
if you're not familiar with Armando, he designs and builds zero energy houses in Texas and beyond, I think, and builds, from what I know, Armando, you correct me if I'm wrong, but you tend to build some pretty big and complex homes, and I saw a lot of thoughts from you in the chat, so I thought maybe I'd bring you on, and since we're towards the end, just ask you for, to share any thoughts you have on tonight's subject matter of advanced framing and the work that you do.
I use advanced framing on every house, whether it's big or small. Obviously, there's some things that I don't think that is proper, like single top plate. I think that's something that it was created 20 years ago with building science, back in the days when they were trying to design the small homes with less lumber. But for me, I use it on affordable housing projects as well as I use it on 15,000 square foot houses. And so I do use pretty much all trusses. Here in Texas, we still use stick frame roofing, and I do it exactly like Mark Guertin was talking about, exactly the same thing. I have the tendency to design for a higher wind design that is required in my area, because as you well know, here in Texas and now we're getting a lot more tornadoes. We're getting a lot more, even in New Mexico now, in Oklahoma, we're getting earthquakes. I'm designing a house in the Napa Valley, so obviously now I have to learn how to, the new areas of Title 24. I'm working with an architect in Maryland designing his house. He's hiring me as a consultant for the building envelope. And so it doesn't matter where it is. I think you can apply advanced framing. I think the details that Mike showed are right on the money. And of course, I'm a building science groupie. I hate to say that things got it downhill here when Steve came on. So I'm hoping that I'm in the situation. But anyways, no, everything I've learned in building science over the last 20 some years, it really came down from building science. So I'm one of those that I openly appreciate their generosity towards the industry.
Awesome. Thank you for sharing.
Yeah. Thanks, Armando. Yes. So Mike and Tim, if you want to share any final thoughts or what is your favorite resource for learning about building science? Do you want to start, Mike? You're unmuted. Any final thoughts or your favorite resource for learning?
Favorite resource for learning? Steve Basic.
Yeah, right. Let me get my pen out for that one. There is so many resources out there. It's just I can't pick one. It's just having the internet and having the access to so much information, be it from Green Building Advisor, Fine Home Building, or Building Science Corporation, or tons of the government stuff, believe it or not, at the Building America program, stuff that's been developed. It's just, you can spend days and just absorb all that. So.
Excellent. Thanks.
I couldn't narrow it down. Mike's exactly right. I think all of you, the panelists or the in the chat, Instagram, Reisinger has been a great resource. Steve's been a great resource. Fine Home Building JLC, Christine, Building Science Fight Club. It's like the Fine Home Building podcast. It's like what my brother does, because he's the one that really gets into the building science, is he never does anything without a podcast playing. So if he's driving, if he's working, if he comes out to sweep, if he can't, it's a waste of his time. He tries to do as much multitasking. So I'll narrow it down and say my brother's my favorite resource because he's listening to all of you. It boils it down. And he can go on and on. So it really is just all this information that's out there. And it's just
Well, Dan's in the chat box accusing you guys of not mentioning JLC to be nice to me. So let's mention JLC because that's a dynamite resource. And I want to second whoever mentioned Instagram, because if you're in the building design world, it's a reason to join. I don't prefer social media in my personal life, but it's a reason to join Instagram.
Yeah, if you follow just the hashtag building science on Instagram right now, there are so many people sharing so many things in the building science realm, whether it's resources, their own projects. Make sure you follow Travis. He will show you exactly what he's doing every day. Well, maybe not every day. Steve, the dog. I mean, you might get dog pictures if you follow Steve.
He looks better than you, Steve.
Oh, and I did want to add two, if you want to learn more about advanced framing, Mike and Tim, I believe, did a Fine Home Building webinar recently on advanced framing. So they go more into detail on the topic at finehomebuilding.com. Well, thank you, everybody. Planned guests and surprise guests and audience and co-hosts and everybody. This was a great talk, and have a good night. Thank you.
Thanks, Mike. Good night, everyone. Thank you.
Thanks, guys.
See you all.
Thanks, guys.